Hello, hello. Welcome, everybody, to another Cypher interview. Today, we have a fantastic guest from Off-Chain Labs, or as most of you know them, the team behind the Arbitrum Layer 2. We have Rachel here. Rachel, how are you doing today?
Hey, I'm doing great. My name's Rachel. I'm a tech lead at Off-Chain Labs, working on a bunch of cool stuff, including Stylus, which we'll talk about a bit today. So Off-Chain Labs is the primary service provider to the Arbitrum Foundation. So recall Arbitrum decentralized earlier, and now it's led by a DAO and everything's voted on and all of that. But we're one of the large companies that actually works on a lot of the technologies that go into various upgrades or what have you. So I'm a tech lead there, and have been building Arbitrum stuff really since before Arbitrum even launched. So yeah, it's been really cool to see it get to the stage, and I'm happy to talk about it.
All right, perfect. Well, we're excited to have you here to talk about it as well. For those of you watching, we do have the comments on, so feel free to ask questions. We'll get to them in a little bit. And obviously, for those of you who do code hawks, competitive audits, you already are aware of Arbitrum, because that's where we do payouts on Arbitrum. So, so the first thing, kind of the most pressing thing, Arbitrum Stylus, Rust smart contracts on an L2 in the EVM ecosystem. What is what is Arbitrum Stylus? How does it work? Hold on, that's too many questions for you, Rachel. What is Arbitrum Stylus?
Yeah, no, there's a lot of great stuff there. So Arbitrum Stylus is an upgrade that Off-Chain Labs is working on and will propose to the DAO that allows you to deploy smart contracts written in new programming languages to Arbitrum chains. So imagine using Arbitrum 1, for example, and not just having to use Solidity or Viper or one of those EVM smart contract languages. What if you could actually write smart contracts written in Rust or C or C++ or other traditional Web 2 kinds of programming languages? So that's in short what it is. It's the ability to write contracts in all these different languages. It's an upgrade that we've been working on. We actually have a test net right now that you can actually go and do these things. You can go write smart contracts in Rust or C or what have you and deploy them and use them on a test net. But we're going to propose that to the DAO, and assuming the decentralized DAO votes for it, you'll be able to actually, on Arbitrum 1 or on Arbitrum Nova or on any of the L3 Orbit chains, use Rust and other languages to design and build your next applications. And I'm sure there's lots to talk about there in terms of its efficiency and speed, but that's just a high level what it is.
Gotcha. Well, thank you for the explanation. In the on screen right now, you can see the link to the site to check it out. So Rachel, I've taken a hot minute. I've gone through the docs. I've built a smart contract in Rust, which was actually a lot of fun, which was really cool to be like, whoa, it's working and everything. So to me, the main question is, why Rust or why C++, or as you said, just other languages, right? Why is this needed? Why is this important? Why?
That's a great question. So there's kind of a few different reasons. To start, Solidity is an amazing language, and so is Viper and all the other stuff that exists in the EVM. But there's not a lot of people who know them. So, estimates vary a bit, but if you look into it, you'll find that there's about 20,000 Solidity developers out there. Meanwhile, there's 3 million Rust developers, 12 million C and C++ devs. There's a multiple order of magnitude difference in terms of just the knowledge share, in terms of all of the people who, already know those languages. So Arbitrum Stylus brings or lowers the barrier to entry so that people who use these other languages can start designing and building applications without having to go learn new tooling, learn new processes, et cetera. And there's actually a Forbes article recently about how some of these credit card companies are finding that it's difficult to actually hire Solidity engineers. There's just not a whole lot of them. If you don't at your company actually know this language, it can be difficult to know how to assess candidates and make sure that you're getting the right people, and not just people who say they know Solidity or what have you. But these companies that have been building games in C++ or financial applications in any of these languages, for them to be actually able to take their code, to use the libraries that they already know and love, to use the tooling that they're familiar with, and just all of that stuff that makes these languages so popular, and so useful in a day-to-day kind of sense. That's what Arbitrum Stylus makes possible. And so we chose to just go after 3 really solid languages to start. So we added Rust, we've got C, we've got C++, but we intend to branch out and do more. But that's kind of like an initial motivation for it. And the other reason too is just that these languages are really fast. They have excellent compilers and tooling and debuggers and all of that. And so like you'll actually find that stylus applications tend to be 10 to 100 times cheaper in terms of computation. So it's not just the barrier to entry is now lower. One reason why you would want Rust is that the stuff is so fast. So if you're thinking about writing like price sensitive applications that perhaps do financial tools or AI or whatever it is, right, that is cost prohibitive or very price sensitive, being able to actually do this stuff on the blockchain efficiently is very important. And so Stylus provides a lot of value there. But we intend to eventually support all the languages that one would want to write smart contracts in, where it makes sense in a blockchain space. And that's generally stuff that's like, systems programming languages. So eventually, if we can, or because this thing targets WebAssembly, something we might talk about, if you want to dive into that, we can actually add all these new languages and stuff in the future. But I'll stop rambling and ask, does that kind of make sense? Or
No, this is great. So like a number of reasons here, right? That just kind of upfront make a lot of sense, right? Barrier to entry is a lot lower. There's way more Rust, C++ systems engineers than there are Solidity devs. So basically you're trying to just make all of my Solidity courses worthless. I'm about it. Just kidding. But also not kidding.
No, the goal is actually choice, right? If it makes sense to write in Solidity, you'd still do it.
100%. And this will allow us to onboard a lot more people a lot easier, right? Actually, when I first got into this space, I worked with a framework called Brownie. I don't know if you're familiar with it. Still love the framework, but it was Pythonic, right? And I knew Python. I was very well versed in Python. It was way easier for me to onboard with Python than, at the time, Truffle was the main thing. I wasn't very strong with JavaScript. Using Truffle was way harder for me than working with Brownie and Python. So it makes sense. Hey, let's give more options. Let's give easier ways for people to get into the space. And the other thing that you said, computation was cheaper. You talked about WASM a little bit. A question that I have for you, and this is the nerdier side of the question for those of you who are watching. As far as I know, when it comes to reading and writing from storage, the actual compiler, in my mind, I'm like, how can you actually make that process cheaper? If you're building an app that's mostly just reading and writing from storage, would something like Stylus have the performance increase? Because that's something that you mentioned as well. You said, hey, like writing these systems level programming language will enable us to have better performance. Where is the performance benefit? Is basically my higher level question.
Yeah. So the performance. It's actually, there's a few different components that give an application its costs, right? There's computation. And in our case, it's 10 to 100 times cheaper. So if you're thinking about doing something involving like generative art, say, where you're doing a lot of calculation or really complex financial primitives like perpetuals, these are the kinds of things where Stylus shines the best. Another aspect where it does really well in terms of lowering fees is anything involving a lot of memory. So RAM, that's a resource that's commonly used. Well, if you need to use it in blockchains, it tends to be really, really expensive. But in Stylus, due to a better economic model, we're actually able to charge for RAM at a price difference that's 100 to 500 times cheaper, depending on how much you use. So for those two attributes, like if your contract has a lot of this, Stylus is probably going to be much, much cheaper. Storage is a little more nuanced. So when we price storage, right, and I say we, pick any blockchain, right, you're thinking about like the long-term costs to increasing state. Stylus doesn't change what the long-term costs are of somebody, say, running a node and now it has just a couple megs more storage that it needs to sync or have, on hand. So when it comes to storage, the fees aren't intrinsically lower there. That being said, the Stylus SDK provides a efficient storage algorithm where when your contract actually goes and touches state, it'll cache a lot of these things. And so that's not to say that like the actual cost of an S store or an S load, those are the Solidity opcodes, or I should say EVM opcodes, It's not that those are cheaper, but that like by using the Stylus SDK, it's easier to write patterns where you do fewer of them. And like something you'll often see in Solidity, people have to kind of like, maybe if I'm going to go touch a piece of state, I might go do it off in a variable and then I go assign that back. But in Stylus, you can kind of just like touch storage. It's okay because the application is smart and the library is able to know, hey, you don't mean in your for loop to do an S load every time you read this value. Like you already have it on hand. And so storage on its own, like if all your application does is storage and you're mindful to not do bad patterns, Solidity and Stylus are going to have very similar costs. But it's the moment you start doing really interesting work where maybe on top of having that storage, you also go perform some kind of calculation or you use some kind of memory to generate something. That's when all of a sudden Stylus starts having much stronger performance characteristics. And so I kind of think that's kind of the key to all this is that it's choice, right? If it makes sense to write your application in Solidity, you should do that. And Stylus doesn't change Solidity in any way. So that EVM equivalent experience that you've always had on Arbitrum chains, that's just like a Ethereum L1, you still have that. So none of this detracts from it. It's entirely additive. But it might make sense, though, depending on your application or depending on the part of your application, to say, hey, I've got this piece of math that I do. Let's go do it in Rust or C or what have you. I've got this fancy cryptography. Let me go and import a standard C library from the internet and just deploy that as a smart contract and depend on it. I will note that when it comes to Stylus, you can mix and match. Your application can be composed of different parts. Maybe you have like a little part that's in Rust. Maybe there's a little cryptography part in C. Maybe the front end to it is in Solidity, right? Maybe all the storage stuff is in Solidity. You could do all this kind of
front
stuff.
end. That would be that's kind of terrifying to me.
Nobody
make that framework, please. Nobody make a Solidity front end. We have enough JavaScript ones.
I more mean on that, like actually on the blockchain. Right, but I know what you're saying.
Yeah.
So what's cool about that is you mix and match and you just go for whatever is the best thing. But I think you'll find that for like the most interesting applications and for the stuff that's currently cost prohibitive on blockchains, Stylus is the answer. An important part about this, by the way, is that all Stylus contracts are interoperable with EVM ones. So if you write a method in Rust, it can be called by a program written in C or a smart contract written in Solidity or another in Viper. And it's because everything uses the Solidity ABI. So there's another nerdy term. The ABI is basically just how contracts talk to each other. From the perspective of the blockchain, like every Rust program in that application layer is pretending to be a Solidity one. So if you've got like a mint method on your Rust NFT, it just works with existing Solidity dApps. So like a DEX written in Solidity can list Rust tokens. So like a Rust token can implement ERC, well, any ERC standard you like. So that's why all this works and why I'm talking about it being choice and you just pick the best thing for your task.
Right. So a big question for me then is, okay, where is this computation benefit coming from, right? So the storage bit makes sense to me. Hey, like the compiler itself, the reading and writing to disks costs, is cost. And for those of you who are listening, this is probably a little bit more lower level. This is we're talking almost kind of at the node level here. But yeah, where is this computation improvement coming from? Is it just that WASM is faster, right? Is it is it something to do with parallelism or like
These are great questions.
Yeah, where's this coming from?
I think the add instruction is illustrative. So right now in the Ethereum virtual machine, if your contract performs an addition, so it takes two integers and adds them together, here's what that looks like. Like here's all the steps that are necessary.
Oh, this is nerdy. Oh, I like this.
This is going to get very nerdy.
I'm ready.
I'm
ready.
All right.
Oh, this is exciting.
The Ethereum virtual machine is interpreted, right? So, or rather, EVM bytecode in the Ethereum virtual machine is interpreted. So that add instruction pops two items off the simulated stack. So it's not like it's just performing an add. It has to actually go touch memory. It needs to go grab those values. And that comes out, or I guess to just start from the very beginning, like if you go to do an add instruction, the first thing that happens is the EVM interpreter says, oh, I'm about to do an add. And so then it accesses an in-memory table to see what's the cost of an add. And so then it performs a little gas charging. It deducts 3 gas. That's how much an add instruction costs. And then after deducting that gas and making sure you haven't run out, it pops 2 items off the simulated stack, doing any kind of tracing that it needs to before that. Then it adds them together, and then it pushes the result to the simulated stack and then increments the program counter. So you can see here, adding 2 numbers wasn't just adding 2 numbers. It's like all these different little steps, right? And each one of them costs time.
And for those of you watching, we're releasing a security course very soon where we're going to go over that exact process. And yes,
awesome.
that it is like these weird like stack stuff. For those of you who haven't looked into it, the EVM is a stack-based machine. It's very cool. Prepare for the course.
Yeah, no, that's exciting. You're doing that. And you'll see all of that too. So when you're adding 2 numbers, right, it's not just adding 2 numbers, it's all stuff that happens. Okay. In Stylus, when you want to add 2 numbers, you just do an x86 add, or you just do an ARM add, depending on what the assembly is for your node.
There's no stack.
There's a stack, but it's your actual operating system stack, right? So it's like, it's not interpreted. This stuff is compiled. And when it comes to gas charging, instead of charging for gas every opcode, so recall, like we charge for gas, then we do an add. We charge for gas, then we do a divide. We charge for gas, then we do a jump, right? That's how the EVM works. In Stylus, you charge for a batch of instructions and then run all of them. And then you charge for a batch of instructions and then you run all of them. And what we find from this is that the difference is it's enormous, right? And so for the add instruction in particular, in the EVM, it costs 3 gas, right? In Stylus, it costs 150 times cheaper. And that's just straight up based on like how that stuff performs, even in the worst case. Like even if you do a worst case analysis, this is just so much faster because so much less is happening, right? To give some, performance numbers that might be illustrative, there's a common, this is a great site, evm.codes. Yeah, if you're talking about doing security courses, you got to get very familiar with this website or all the things in the Ethereum yellow paper. You'll see the add instruction costs 3 gas. In Stylus, it's 3 divided by 150. So a lot less. And
so in that speed up comes from the fact that you're batching that it's mind baffling to me. And yeah, everybody who hasn't seen this is the phenomenal site for like learning about opcodes and stuff. As Rachel was saying, every single opcode has a minimum gas associated with it, and this gas basically is calculated. The community has kind of calculated how expensive it is on the hardware to run these operations, to cope with these. It's mind blowing to me that you're saying it's what did you say, 1/100th the cost?
1/50th. You can do 150 ads in Stylus in the time it takes to do an EVM ad.
What? And that's because this might be a low level thing that takes me a while to wrap my brain around. It's because you're batching them. So what if all I'm doing is add though? What if that's the only thing I do? Would it be the same cost?
It's the same. And it's because, theoretically, like if your application just does a single add, you don't get the theoretic performance benefit of, batching, but real world applications have tons of instructions in them, right? And so the batching algorithm is going to be quite efficient. But I will say when it comes to add, so it's the fact that we batch, it's the fact that it's compiled and actually uses your native assembly instead of using an interpreter. And then it gets even better actually, because not only is an add instruction less expensive, you do fewer of them. So the compilers for languages like Rust or C or C++, they have benefited from decades of engineering and research and the academic community coming up with these optimization algorithms and passes. And so the same program written in Solidity and written in Rust, right? The Rust one is going to just have a much more efficient compiled output. And that bytecode that you get, in our case, WASM, right, which we then lower to your local assembly, it's going to have fewer ads in them, and each of those ads takes less time, and therefore it takes less gas to execute.
So in like a weird analogy, let me know if this works, because the compiler part makes perfect sense to me. Again, in the security course coming, you all should watch that. It's going to be sick. We break open, the Solidity compiler, we go into the compiled stuff, and we'll often see like it's doing this weird thing here. Why is it doing that? Like it would be better if we swapped or we did this or whatever. it's very easy to almost like fight with the compiler just because it hasn't been around as long, right? There hasn't been enough elbow grease dug into it to make it amazing. But the analogy that I want to make here is it almost sounds like you're saying, hey, it's way faster because it's closer to what our machines already do, as opposed to kind of this new abstract EVM thing. Is that a good analogy, or is that
I think
too
you can
far?
look at it that way, right? Like when you interpret, you pay for that, and we don't interpret. I think, yeah, I think also, by the way, you brought up the security thing. Stylus contracts present a very interesting auditing opportunity, you see, because right now in
Security
Solidity,
alpha, security engineers,
yeah,
pay
security
attention.
engineer
You're
alpha.
dropping the alpha right now.
So, and I've talked to auditors about this, and they're very excited about Stylus, and here's why. Like in the Solidity world, you have to do what Randall Monroe from XKCD calls code golf, right? Like, hey, how should I increment the variable in my for loop? Do I do this here or there? Oh, this weird bit shifting was way cheaper, right? In Solidity, you play all these games to eke out, better and better performance numbers. And this stuff is very dangerous to do. And because it's error prone, right? Like if you're over here optimizing by hand, you make one mistake and that could be life and death when it comes to your application, right? Whereas with these new languages, right, because the compilers are so fast and so good at optimizing, you don't have to play those same games, right? Like the Rust compiler can generate a really good for loop. You don't have to like play with the variables, right? The academic and engineering communities behind it have already figured this out for you. And so Stylus code isn't just faster. It's not just able to leverage new libraries. It's not just all those great things that make Web 2 languages great. It's also the fact that it's easier to read, easier to audit, and more likely to be correct. I think another really good example too. Right now in the Ethereum world, we often see people not doing the right thing because it's just a little too expensive to add safety. Reentrancy is so dangerous, right? And you see it everywhere. And in fact, it is enabled by default in most contexts, right? And that's just because detecting reentrancy in the EVM is very, very expensive. But in Stylus, detecting reentrancy costs only 2 gas. So you can know a priori if you've been called reentrantly instantaneously, right? With just a negligible amount of cost. And so every Stylus program by default, every Stylus contract rejects reentrant patterns. Now you can, opt into them, but that's important, right? You have to opt in. You have to actually say, I want reentrancy. And so Stylus doesn't just make things cheaper, it actually makes things safer. And so I think it'll just become a very solid standard going forward when people want to write decentralized applications with real world money on the line.
It's interesting you say that. This was one of the conversations the Viper compiler crew was having about, hey, do we just turn off reentrancy by default, right? Because of exactly what you said. But it had some debate because they're like, it's like way more gas. I mean, it's the same thing with, again, very low level for the nerdy people here, which actually, what most of you are, so great. The unchecked versus checked on overflows and underflows, right? Solidity eventually just said, yep, we're going to check it. Like too many people are hitting overflows. And now on every single gas competitive audit, you always see people up. You're doing a for loop. You better do an unchecked because that's going to be way more gas efficient. But you just start seeing these horribly unreadable ways to do things, as you're saying, or like one of the ones I always see is, use assembly to emit events. Yeah, that works. But, if somebody reads this, they have a very hard time knowing what it's doing. I feel like very few people here have actually done a smart contract security review on assembly contracts. It's difficult. Like 100 lines of code maybe normally takes you, a day, maybe less than a day. 100 lines of assembly, you're talking a few days, just because it's so much harder to wrap your head around what it's actually doing. So Rachel, so to me, this brings up almost like a more crazy, wild, out there question. So it sounds like there's all these benefits to doing this, right? It sounds like this is objectively better. Maybe we got to unpack some of the faults of this. Maybe there are faults, but if this, let's say for now, it's just objectively better, right? Would the ETH ecosystem move to this? And then maybe you can't speak to this. Do you think this is something that the ETH ecosystem should move to? Or you're like, no, it's better for L2s to do this? We're getting into a philosophy a little bit here, but I'm curious on your thoughts on, hey, maybe all of the ETH ecosystem should adopt this versus, hey, maybe this is better for L2s? Where do you see this going?
Yeah, I think first, one of the things that's so exciting about the new L2-centric roadmap that Ethereum has is that different L2s can provide different kinds of ecosystems, right? And so Stylus, provides an opportunity to get to use WASM stuff, even though you don't really find it in other, EVM contexts or in other L2s. And so I think it's beneficial in many respects for layer twos that they can do this, that they can innovate and they can come up with their own things. But I do actually think it would be really cool to see this on L1 as well. So you might not actually know this, but layer one, way back in the day, had this thing called eWASM. There was this push to maybe see if we can add WebAssembly to the EVM. And I think that's a super great idea. I will say back in the day, WASM wasn't as mature, right? And it was a bit earlier. And so figuring out these things from the start was a bit harder. But now that we figured out how to do this on layer two, it becomes clear to me that yeah, there you go. You have it. And it would be really neat to see something like this, to see Stylus on L1. Having learned the lessons that we have from layer two, from, the eWASM days, all of that stuff. So I think it'd be really neat to see Ethereum embrace more WASM technologies. It is the future. I think there's a great quote I often bring up. So Solomon Hykes, one of the co-founders of Docker, Docker being that friendly, if anyone here is technical, they'll know what Docker is, but it's an amazing DevOps tool. Well, with huge market share. He actually said that if WASM had existed in 2008, they would have never needed to make Docker, that everything could have been done in WebAssembly. And that's quite the endorsement, right? Because Docker is huge. And as Solomon argues, he said that WASM is the future in terms of server-side computation. And I think blockchain is a very natural extension of this. And so, I understand that in the past, it was a little tricky when WASM was a bit brand new, but it's got so much industry support now, and it's grown to become quite large. In case we haven't actually explained it, WebAssembly is made for the web. So it's not just a blockchain thing. You'll find that web browsers like Chrome or Firefox or Safari and other server-side instances used by these big Web2 companies, they actually use WebAssembly as a compute acceleration engine. And it has all these benefits as a instruction set. It's sandboxed, it's really fast. And because you have all of these big companies working on it, if Ethereum is to adopt WebAssembly technologies, they get to then leverage just all that free improvement, all that free tooling and ecosystem support and amazing stuff that's been built on top of it and with it. And so, Arbitrum Nitro, was our first foray into actually, using this stuff in terms of our fraud proofs. And Stylus just makes it possible to take that same WebAssembly tech and do it in user applications. And I think it would be really cool to one day see just Ethereum go all in when it comes to WASM. But it is something that's up to, the decentralized community that makes up Ethereum. That's a conversation that needs to be had with, all voices heard and what have you.
Yeah, I was going to say it's up to us collectively. Yeah. So who's going to put the EIP to be, hey, let's add Arbitrum Stylus to ETH mainnet? Maybe somebody does that someday.
Yeah, an open standard version, Yeah. That'd be really cool, something more neutral, but it'd be really neat to see these technologies adopted.
Yeah, definitely. I appreciate your insights and your thoughts there. So Arbitrum Stylus, obviously really cool. And actually a couple people posting in the comments here saying, hey, when Rust course, right? The other thing that's really cool about this is there are other blockchains as well that use Rust. You could write it in Arbitrum Stylus. Arbitrum Stylus is an SDK, and you'd be good to go, which would be really cool. Obviously, give you the alpha there. Now, you mentioned something that I do want to dive into that a lot of people, I feel like, so yeah. So Rachel, let's just, everyone here is technical. Let's be honest. Anybody watching this channel right now is technical, probably security focused. So they're probably really interested in the alpha. So you mentioned a couple things though. I feel like this is lesser known, like Nitro, Orbit. What are they? How do they fit into the Arbitrum ecosystem, the Arbitrum view? And then now with Stylus coming out, how do they fit into, what are Nitro and Orbit?
Yeah, absolutely. So Arbitrum Nitro is the node software that powers Arbitrum nodes today. And this is for all networks. So whether it's a layer 2 like Arbitrum Nova or Arbitrum 1, or it's a layer 3 like these Arbitrum Orbit chains, which I'll explain in a second, they're all using Nitro. Nitro is our node software and fraud prover. So when someone's using or validating our chains, or I shouldn't say our, but our in terms of the whole ecosystem, our whole community, when people use these Arbitrum chains, they're using the Nitro node software. And Nitro was this big breakthrough where in the past, back in what we call the Arbitrum Classic days, we had a lot of custom stuff, our own custom programming language in terms of implementing the node software, a lot of things that were a first foray into like how you should do fraud proofs. But then Nitro came out and it brought WebAssembly fraud proofs. Okay, so that's Nitro, and that's like a bit technical and a historical thing. But Stylus is an upgrade to Nitro. So any chain that's using Arbitrum Nitro will be able to adopt Stylus. So if you've got a chain that's running on layer 3 or running on layer 2, when Stylus comes out, you'll be able to just make the upgrade. And when it comes to layer 2s, that means the DAO is able to just pull the switch and make it possible to start building all these applications in Rust or what have you. Arbitrum Orbit is a version of Nitro that can be run at layer 3. So instead of running your own layer 2, you can actually build on top of Arbitrum, whether that's Arbitrum 1 or Arbitrum Nova, and have your own chain. And for certain applications, this makes a lot of sense. If you want to like customize your virtual machine, if you want to add new precompiles, if you want to add like all these new behaviors, right? Being able to take the Nitro node software and go deploy it on top of an existing Arbitrum L2 gives you a lot of experimentation and performance improvements and a lot of good stuff there. So that's Arbitrum Orbit. Another thing we have coming out is Arbitrum Bold, or we just call it Bold. So Bold is an upgrade to Nitro that allows us to have permissionless fraud proving. So right now there's a whitelist. If someone wants to validate an Arbitrum chain, they're able to see that it's working and acting correctly. But if you wanted to actually like dispute fraud or do fraud proofs, there's currently a whitelist that is on layer 2. And the idea with Bold is, assuming the DAO accepts it, because recall this is decentralization and people vote on it, people will be able to run their own validators, right? So you'll be able to actually run a validator that doesn't just validate the chain, but that actually fights for its correctness and disproves fraud and all of that good stuff. So all these things are happening. They all plug and play with each other. Arbitrum Stylus is coming not just to Arbitrum 1, not just to Arbitrum Nova, but also to Arbitrum Orbit. Bold similarly is going to power everything, and it's also Stylus compatible. These are all initiatives that work together, and that I think the DAO will be very, very excited to adopt when ready. So hopefully that answers your question a bit.
No, it does. It actually paints kind of a brand new future, right? So we're talking about Ethereum scaling, right? At the end of the day, and we're saying, hey, we're going to scale with Arbitrum as this L2. It has fraud proofs. It's optimistic rollup. Now we're talking about with Orbit, we're talking about an L3. So a rollup to ETH, right? That, like, what is the main benefits of this? You mentioned, hey, like some applications might make sense. What are some of the applications that might want to do this L3 as opposed to deploying, maybe directly to Arbitrum or an L2?
Yeah. So any kind of application that wants to actually modify the chain itself. So for example, having your own custom fee token, or maybe you want to go for some privacy primitives or something, right? Like recall that Arbitrum 1 and Nova, like these are not privacy chains. They work kind of like Ethereum does. But if you wanted to have those kinds of features as central to your product, it would make sense to have like an actual chain where this happens on. So anything where you're doing like really, really custom stuff. And we're seeing people in the gaming space doing this kind of thing and, working on these Orbit products. And so, the sky's the limit, right? You're able to edit this thing however you please. It's cheaper. It also has some benefits over like launching, an all L1 because you get to be connected to all of the Ethereum stuff that's happening. But when compared to a layer 2, it can be cheaper in a few different senses. Like one that's really interesting to think about is like, if you launch an L2, while it's true that Arbitrum Nitro has really, really efficient batch compression. So if like you have a bunch of transactions happening, it does a lot of compression and batches them together. It does some very intelligent behaviors, right, to lower fees. If you don't have a lot of volume, compression can only do so much. If there's only like ATX that we're going to include in a batch, it's not going to get to compress with a bunch of things. But what's cool about an Arbitrum Orbit is that even a low volume or low activity application is able to compress into the layer 2 batch. And so you get to take advantage of like the scaling and also just the lower gas of layer 2 on your layer 3 chain. So it depends on the application. It depends on how big one is thinking in terms of the customizations they might want. And it depends on, just if you want to have ownership, if you want to have your own token, if you want to have this or that, why someone would want to do an Orbit chain. But yeah, I think it's a really exciting thing, and we're seeing people building on it today.
Gotcha. Awesome. Very, very exciting. So basically in the future, somebody could basically run their own Orbit L3, their own customized L3, all the smart contracts written in Rust, and it'd be basically fully compatible with Ethereum, even though the tech stack is completely different.
Yeah, you can do this. And you could choose to have both Rust and EVM stuff by, adopting Arbitrum Stylus. So what's cool about that is like, because Stylus is additive, an Orbit chain can just choose, do I want Stylus or do I not? If it wants to be only EVM, it can. If it wants to add Stylus support, that's a very, very simple thing. You just adopt the upgrade. And theoretically, I guess if you wanted it to be Rust only, you could prohibit EVM apps. But I kind of think it's very important to have EVM stuff, like something that's really, really at the heart of scaling when it comes to these languages. Like there are chains out there where you can use Rust or where you can use C. And the problem is, though, they're siloed, right? So like you have all of this huge liquidity on Arbitrum chains, right? Arbitrum 1 is enormous. If you just look at the DEX volume, it's second only to Ethereum. If you are a Rust developer, right now, the value proposition is, oh, I have to go find a chain that has Rust, right? And while those might exist, it's not the best Rust. Oftentimes there's a lot of friction. But more than that, you just don't have access to the ecosystem or liquidity, right? And with Arbitrum Stylus, right, being able to say, hey, I'm going to launch my Rust product and it's going to interface with all that existing ecosystem goodness on Arbitrum 1, that is really, really important from a business perspective. So I don't think it should be either or, right? I think it should be both and. You should have the EVM and you should have Rust. You should have the EVM and you should have WASM and C and all of those things, Solidity and your favorite languages, and just have them all work together in one unified ecosystem.
Gotcha. Definitely. 100% agreed. So we have 20 minutes left here. I would love to answer one question from the audience. Sure. And then do you think we have time to do a quick little hello world of Stylus?
Yeah, we could do that.
All right, cool. Lovely. Okay. So John, great question here. Do you think adding another layer makes it more complex for user interactions? For example, right now, if I want to go to Arbitrum and my on-ramp to crypto is, an exchange that only does ETH. I go to ETH, I bridge to Arbitrum. Now I have to do this third bridge to the L3. Now you're talking about fractured liquidity. Maybe there's less liquidity on this L3. Like, how does this, do you think this adds more do you think this adds more complexity?
So it's a complicated question. On one hand, like if your L3 is really popular, right? Getting support for people to be actually, having having on and off ramps that are just like native might actually be possible. But I will note, you don't have to go to Ethereum and then bridge into Arbitrum and then from Arbitrum bridge into the L3. Most all the big exchanges, I think all of them do, they support Arbitrum 1. And so you can just like directly, pull your ETH put your ETH onto Arbitrum, and then you could go from there to L3. But if an L3 is, sufficiently popular, you can imagine them also having direct on-ramps. There's also really nice coordination primitives that are possible between L2 and L3. These aren't currently there today, so I don't want to say that like right now, the fractured liquidity questions and stuff like this is completely solved, but it's the kind of thing that we're going to. And when you actually have like the thing built on top of the L2, a lot of really interesting stuff is possible. So we're actually working with Espresso Systems on decentralizing our sequencer and stuff, and there's a lot of interesting things we're thinking about there. But it's just going to depend on your application, right? Right now, given where Orbit state is, we actually just announced, or I should say, the Arbitrum Foundation just announced that Orbit is mainnet ready, so you can actually go use this stuff today and go and deploy your app. We actually have like an interface where you can just like one-click deploy, and then bam, you now have an Orbit testnet set up. And the same thing works for. You can do the same thing for mainnet. Well, all of the stuff is hot off the presses and is we're making a lot of progress on. But that's the current state of things. I'm really excited about it. It's all going to have Stylus, but it's just going to depend on your application if it makes sense to do that. Or for many applications, it makes sense to just be on layer 2, right? Like you don't have to go do your thing on an Orbit chain. If your app, wants to tap into L2's liquidity today and everything just like work out of the box, you should just deploy it there. That's kind of how I see it.
Yeah, just to kind of double click into that, I agree. I think at some point we will get much better at abstracting away kind of all these jumps that we have to do right now. But yeah, hopefully at some point we'll abstract away. John asked a follow-up question. Hey, do most hot wallets have L3 interactions? I've seen L2s, but not L3s. Just to kind of quickly respond, you could easily add an L3 into your hot wallet. If you're using MetaMask or something, you just add a new RPC. Boom, no problem. Cool, great. Thank you for those questions. Would love to jump in a little Hello World. The other thing that's really interesting about this is I made my Hello World stylus a couple months ago now at this point. And since I've made it, there are now way easier ways to do it because you all are shipping crazy fast. You are shipping a lot of changes, a lot of pushes, making it better and better, better. It's an alpha now, correct?
Yes, Stylus is an alpha product. So the SDK, that's the thing, that's the library you actually use to build Stylus applications. It's in alpha, and that means that things are rapidly evolving. So features, we're adding new features, we're making some things nicer. I remember I think it was actually very, very shortly after launch that you were working on some of that stuff. And we've made some major quality of life improvements, and we're going to continue to do that. So this is currently in alpha, but what I'm happy to say is that the core stuff is there. So you're able to write your app. It is fully interoperable with Solidity. You can actually, by the way, you're going to see here as we go through this Hello World together, you're actually able with your Stylus app to, let's say it was written in Rust, right? You can export a Solidity interface that someone else can go include in their Solidity project. This is also useful for explorers and stuff because you can, actually know what the API is for a given Rust smart contract. And so what's cool about that is all of the main things are there. You're able to write smart contracts. You're able to, have them connect to Solidity ones and et cetera. But there's additional quality of life improvements we want to make, additional features we want to land. And so we're working hard on that stuff, but it's all usable today. So you can actually go on the testnet right now, as you're going to see us do, and go build on this stuff and just see what we got. Yeah. So how do we want to do this?
Oh, yeah, let's do it. Well, I guess we'll start with a quick share screen, and we'll pop it open. And yeah, we could just go right from the SDK docs. We could do that.
Yeah, here's a link to the SDK docs. Let me do the quick start. Let me link you that. Yeah. That's a good thing to jump to. I'm happy to do it on my screen, or if you want to do it on yours, either works.
Oh, well, what do you think is more fun, if I do it or you do it?
Maybe I'll do it just for simplicity. Okay. All right, sure. Just because I already have Rust installed, and I guess you do too. But
yeah, I have the contract. Excuse me, the project that I did up, just in case we wanted to go there. But yeah.
Why don't you share your screen? Let's do that.
You want me to share screen? Okay.
Yeah. If you could open a terminal.
Let's do it. Let's do it. A little. Actually, let me open up a new folder.
If it's been a bit too, you'll want to upgrade to the latest tooling.
Perfect. A little peer programming here, huh?
Yes.
I'm about it. All right.
Awesome. Yeah. So
code. Let me just set this so people can see here. All right. Let's do it. I'm Solidity developer. I would love to do Rust. These performance upgrades, Rachel, they sound amazing. I want to get my hands on this. How do I do this? Where do I go? What do I
Absolutely. So the first place you go to is our quick start guide, which shows how to go get testnet ether and where how to download the software. But what you'll see when you read that, thank you for linking that. What you see when you take a look at that page is you first install our tool. It's called Cargo Stylus, and this is just a command that you're able to, this is just a command that you're able to execute. So I pasted it in chat, and you actually already have it, and you can install it with the install thing that I showed. But and if you're out of date, by the way, or you have like a really old version, you can just rerun the install command. It'll bring you to the latest version. So
and for those watching, all of this is in the quick start. But yes, we're going to do this little upgrade here. We're going to cargo install force Cargo Stylus so that we're on the latest version. I definitely was on an outdated version, so we're going to get that right now.
Yeah. And so, yeah, we're building Cargo Stylus. And, what's cool is like the quick start guide will also show you like how to download Rust and anything else you need. You'll also need like testnet ether. So there's a Stylus testnet, as we've been talking about. And we actually have there's faucets you can go to get ether for free. So it's not hard to come by. But we'll be doing all this on a testnet instead of, burning money on a live production chain. But
although for everyone who's watching, you all know testnet should not be the default. We want to test everything locally before we ship stuff. Otherwise, you're going to be draining those faucets a lot and wasting a lot of time. It's going to be way faster for you to write your unit tests, your test suite. You all should be aware of fuzzing. You security people should be aware of fuzzing. We'll do this at some point. So, John, what testnet is this? This is actually the Stylus testnet. So this is a testnet specifically for this. Sorry, Rachel, I stole your thunder a little bit there. Specifically for this upgrade to the Arbitrum ecosystem. So yeah, Rust stuff usually takes a hot minute to install.
Yeah, and it can take a minute. It also depends on networking. But the Rust Rust has a lot of benefits. The one disadvantage that Rust has is that compile times can take a second. I do like that Cargo install has it built from source, so you're not just getting a binary where you have to just trust us that it's correct or whatever.
Yeah.
You can go look at the code that you're installing, and then it goes and compiles it. It's just better in terms of security that way.
Well, I would argue that the trade-off is still good too, right? So it takes a little bit longer to install, to build, to compile, but running it is usually way faster. So, I mean, someone like myself, I love the Python language. I will never not love Python. However, when I'm running a Python command where I've got hundreds of functions, I don't love that because it's very slow, because it's not a compiled language, right? So it just takes a lot longer to do everything.
Absolutely. And I will also note, by the way, this is this command we're running here is just to install Cargo Stylus. Actually, building WASMs in Rust, much faster experience. You're not compiling a million dependencies, and blockchain applications tend to actually be pretty slim. It kind of makes sense to have things be, really minimal so that the thing can be small and so that the thing can be fast and all of this. So, I don't think in terms of your day-to-day development experience with Stylus, it's going to be super slow. But yeah, installing this tool can be a little bit.
Which is all good. This is usually a good time to go get some coffee, go get some water, go for a walk, go outside. None of us go outside enough.
Yeah, we need to.
So when you're installing this at home, go outside, go for a walk. I probably should have updated this before we got on, but
no, it's all good. I can also run it myself too if you needed me to. But
all good. Ice cream, yeah, John, ice cream. So in my courses, I've been telling people to get ice cream for some reason. But then what's funny? After I started doing that, I was like, oh man, all the lactose intolerant people are gonna hate me because I keep telling them to get ice cream, and they're like, I can't eat ice cream. So I know what you mean.
My husband's allergic to milk, so we have to get him almond milk ice cream. But this stuff does exist at the store.
Yeah, so maybe I'll stop telling people to get ice cream, John, unless you like ice cream, in which case I'll continue telling people to get ice cream. So, plenty of options these days. Fair enough, actually. Milk-free ice cream. Yeah, as Rachel just said, almond ice cream. So yeah, a good point. You have no excuse to not get ice cream. Go get some variant of ice cream that you can eat, even if it's test tube ice cream. Whatever it takes.
Test tube ice cream.
Go get your ice cream. Yeah, the perfect ice cream that nobody can be allergic to. But cool. Yeah, I would argue this is definitely not a disadvantage because this is the longest part of the whole thing, and then everything else is faster.
Absolutely. Yeah. No, and also your day by day work with this. The cool thing is the Rust compiler reuses stuff you've compiled. So like the first time you do anything, it might be a little slow because it has to pull in dependencies, it needs to compile them. But what you're going to find is that, actually, once you've built your app once, you make a couple changes, you don't recompile the whole thing, you just recompile that like one part. Oh, that's a good question. So John asks, Foundry is built in Rust. Yes, it is, and it's super cool. Rachel, is it worth learning Rust in the future? It is absolutely worth learning Rust. Rust is kind of everywhere now. Like, in the past, it was more experimental, but you'll find that like Foundry and there's this great set of tools built on top of what's called Alloy, one of which is Stylus. And, a lot of really cool Rust stuff is happening. And you'll actually see a lot of these layer twos. The actual code base will be written in Rust. So, it might be say it's a ZK system that uses, Ethereum, like tries to be EVM compatible to a degree. While it might be running EVM bytecode, the actual like implementation will be in Rust. And so if you're thinking about like jumping into Web3 and you're like thinking like, what do I need to learn and so that I can actually do this and get employed and like start building these things professionally, Rust is an excellent language. Yes, learn Solidity as well, but you're going to find that if you learn it, it's going to take you very far and let you work on some really, really cool stuff. Actually, speaking of which, by the way, if anybody's like thinking, hey, I want to get a job in Web3, you should apply at Off-Chain Labs. We build Rust stuff all day long. So this isn't like we have a little bit of Rust. We get to like work on this 24/7 with some of the coolest people you'll ever meet. So if you're thinking about making the jump into Web3, now is an incredible time to do it. If you're thinking, how do I one day do it? Learn some of these languages, build a couple Stylus apps, see what happens when you deploy some contracts. And it'll take you very far.
100% agreed. 100% agreed. So this is just about done. Now, what are we going to be doing when it installs? What is the command we're going to be running?
Well, what's cool is you could start from scratch, but we actually have a nice tool. I mean, we have a nice command you can run, cargo stylus new, and then the name of the thing you want to make. So, you could call it whatever, maybe video or something. And yes, wow project. And what's cool about this is actually going to not just, it's not just going to give you a blank canvas. It'll actually give you a nice like Hello World program where you get a counter contract and you can kind of start from there. So you don't have to, build this stuff from scratch. You're able to, work off a nice little like template, but you can also build it from scratch, but you're going to see this is like a nice smooth introduction.
Like nice smooth introductions. We like a little Hello World action.
Absolutely. We got 2 things we need to build.
Two
One
things.
now.
Almost
here
there.
We go.
The binary for cargo stylus. It might not be loving the number of tabs I have open in my browser. That might be.
You're all good. The more cores you have on your machine, the better it'll go. All right. Let's. In a second, you're going to be able to paste that in.
Here we go.
All right, we got it.
Wow project. Boom. We got it.
And that right there just made in your directory wow project. And you're going to see in the source folder, you actually have your code. So there's 2 files. There's a lib.rs. That's where most of your contract code is. And then there's a main.rs. And the lib file, if you look here, is a counter contract. So this is like a really, really simple canonical example that essentially implements something you could write in Solidity, but in Rust for comparison. I see you highlighting a piece of it.
Right at the top here, yeah, we have contract counter. This is just perfect Solidity, right? So we only have a couple minutes left here, so I do want to kind of do a quick walkthrough of what this looks like for people who are new to Rust. Let me can I do the quick rundown? Just
go for it.
All right, cool. So cargo, this is kind of like your config file, basically, in like a Node.js project, or more simply like a Foundry project. This is your foundry.toml, right? GitHub, this is obviously just going to be stuff related to GitHub. We can kind of ignore that right now. Counter.rs, what's interesting about just give me examples, this is kind of like your scripting. Exactly. Example how to interact with a deployed contract. So this, if you're familiar with Foundry, this is kind of similar to script. Licenses are obviously licenses. SRC, this is exactly like Foundry. SRC folder, this is where our smart contracts are. target. Target always. How do you explain target actually?
So target's generated by the Rust compiler. So it won't be there at first, but then when you go build your thing, it'll get populated with like your binary.
Great. And then we have cargo lock and cargo toml. These are basically package managers. So actually this is more like foundry.toml, but these are basically for managing packages. And then obviously cute little header and then a readme that comes with it. So yeah, in the interest of time, so as Rachel said, lib.rs is going to be our main contract information. And a lot of this stuff is going to be different if you're coming from Solidity. A lot of this stuff is going to be new, but once you get into it, once you actually work with it, it all just starts to, for more sense. But the thing is, you're going to see like this is this very small Solidity counter contract here. There's actually a lot more. Well, actually not that much more, but there is more code, and that's because, again, this is I would argue this is a much lower level programming language than Solidity, right? Technically Solidity is like kind of low level, but I would argue this is lower level, so we need more stuff. Is that right, or you're like?
I think in this case it's actually just because there's a bit of boilerplate. But I think what you'll find is as you start writing complex applications, it's less lines of code. Just because Rust has like a lot of really nice language features like generics and zero cost abstractions like iterators and stuff. And so yes, like the just default hello world contract, especially with all these comments you're seeing everywhere, it's more code for sure. But what you'll find is like when you actually implement with this stuff, you get to take advantage of libraries and of like, consider if you wanted to like edit a byte array in Solidity, you often have to escape to assembly. And that starts adding a bunch of lines of code, and not just a lot of lines of code. You have to add documentation if you want it to be comprehensible and auditable and all of that. But in Rust, right, you just perform very simple operations on vectors or slices, right? Because these things are like first-class primitives in the language. So I think there's that. By the way, actually, it was fun that you pointed out licenses. The Stylus SDK is open source. So anything you build in this gets to take advantage of our open source SDK. And you can, of course, choose to license your stuff closed source, open source, however you like, because the Stylus licenses are extremely permissive. It's Apache 2.0 or MIT at your choosing. And it's kind of hard to think of projects where that is not license compatible. That's basically as open source as it gets. So yeah.
Awesome. So we only have 1 minute left here. So I do want to kind of I'm just going to speed through reading this README real quick. For anybody who wants to give this a try and wants to give this a whirl, it's incredibly satisfying. So you just go to the quick start in the docs there, grab some testnet, Arbitrum Stylus testnet token, and then stick it into your, it's exact same user experience that you used to. Stick it, put that into whatever wallet address you want. Then you can deploy like this, which you are 100% going to use a private key different than your production one.
Yes, please don't repeat your private keys.
Yes. Yeah. Anybody who's watched my course, I made you all promise and comment and swear you would never use a developer key with your money in it. So you will use your developer key to deploy, and you'll actually be able to see it on the testnet if you want to try this out. And what's really cool, what I had a lot of fun doing was going back to this and actually trying to say, and this is how I felt it was the easiest for me to really learn coming from Solidity, was okay, well, what if instead of set number, this was like set name, string memory name, and then we have, string public name. That'd be shadowing a variable underscore here. Just make a real simple adjustment, real small adjustment like this. Boom. And then contract my name or something. And just tinker it. Hey, how would I make this? I know exactly how to do this in Solidity. That took me 2 seconds to make this in Solidity. How can I make this in Rust? And doing little small stuff like that, running the compiler, running the check to see, oh, yeah, actually, we should probably run the check.
Yeah, there's Cargo Stylus check. There's also Cargo Stylus export ABI. So you can actually see what the Solidity equivalent of the thing you have is. Let's see here. So, all right, there we are. Now we're in the right directory. So that'll actually build it for the first time. And then there's also, I'll paste the command here. There's cargo stylus export ABI, and that'll actually show you like what is the Solidity equivalent of what you did in terms of the interface to it. And yes, you can use that to go and, connect it to a Solidity contract, but it's also just useful to like see like, oh, this is how my thing interacts with the world.
So if we're going to do CD, wow, oops. So we're running the check in the other terminal. We're going to run this export ABI because we have this Rust smart contract. We want to see what this looks like in Solidity. It looks like we should have number, set number, and increment. These are the three functions that we have. Again, remember in Solidity, if we have a public variable, like we do up here, this is secretly like creates a getter function. So in Rust, we actually see that a little bit more obviously, where that number variable that we would normally call is actually a function itself. We'll see that in the output down here. And it looks like it compiled perfectly. Hey, here's the uncompressed size, the compressed size. It even gives us the endpoint that we should use to deploy stuff. Program success stylus on-chain activation checks with stylus version 1. Very exciting. And then this will give us the ABI. Oh, it failed.
Well, if you run this locally, it'll probably work. But yeah, so the idea too, another thing too on how long it was taking to do each of these things. The cool part is if you've done it once, then running it a second time, it'll be cheaper. I mean, it'll be way faster. But here's the cool thing. All of the stuff that we're talking about right now, you can go use this with our quick start guide. So like we actually have a tutorial that like takes you through all of this stuff. And hopefully answers like any questions you might have or system configuration things that you need to do. Yeah.
Gotcha. No, this was phenomenal. Hopefully everybody here learned a little bit. We're probably going to do a stylus video on my channel as well. But yeah, so Rachel, where can people find you and learn more about stylus?
Yeah, so on Twitter, I'm at cryptoiscute. But you can also go to the docs.arbitrum.io and read about our documentation there. There's a lot of cool stuff. If you just Google for it too, it pops up. Yeah, we also, by the way, we have a stylus Discord channel. So if you go to the Arbitrum Discord, and you can just go to Arbitrum, make sure you're looking at the right Twitter account because there's a lot of like fake ones. But if you go to the @Arbitrum account, you'll see that there's a link to Discord, and that Discord has a stylus channel. So yeah. That's how you can reach me and other people and get started with it all.
Perfect. All right. Well, Rachel, thank you so much for being here. Really excited for the future of stylus. Really excited for all these new changes coming out. It sounds like the future of Web3 is looking brighter and brighter thanks to changes like this. Thank you so much.
Yeah, thanks. Appreciate it.
Bye all.
Bye.